Welcome, and thank you for joining our webinar on AI-powered collections. Today, we will cover a few things, including what artificial intelligence truly is, the applications of AI in collections, debt recovery, and accounts receivable management, scoring strategies, as well as the NLP Logix Paypensity approach. My name is Samantha Hartman, and I'm the Director of Marketing here at NLP Logix. And with me today is our lead statistician and one of the masterminds behind Paypensity, Katie Bakewell. If you have any questions, please submit them using the comment section, and we will try and answer as many of them as we can at the end of the webinar. Now on to the important question. Who is NLP Logix? NLP Logix is an artificial intelligence company based in Jacksonville, Florida, with clients all over the US. We specialize in machine learning, predictive modeling, and process automation, as well as advanced analytics. We offer 3 vertical market solutions, as well as a plethora of custom solutions for our very unique clients. We also have over 5 years of experience in the ARM space and have worked with enterprise level collections agencies to help fine tune our solution. Now I'm going to hand it off to Katie Bakewell to explain a little bit more about artificial intelligence.
Intelligence is an industry right now that gets tons of press. It gets all kinds of buzzwords attached to it, and really all artificial intelligence is a system that allows a computer to do something that a human might want to do or a human can do. So one of the subsets within artificial intelligence is machine learning, and that's where NLP Logix focuses. So machine learning, instead of me telling a computer what rules to use in order to make decisions, we teach the computer to learn from data and make its own decisions. Deep learning is one of the most popular buzzwords right now, and those are neural network-based models. So they're models that are made after the human brain. And they're really great models. They're fantastic for things like computer vision. But what we found for debt recovery is staying in the machine learning space with a little bit more robust models offers the best performance. So one of the things that we find really important at NLP Logix is to treat data science like a team sport. Anybody who's tried to hire a data scientist knows there's no really strict definition of what a data scientist does. It could be a Hadoop engineer, it could be a statistician like myself, or a BI analyst. So what we treat data science as at NLP Logix is a set of 4 skill sets. So that can be mathematicians and statisticians, software developers, and BI engineers in combination with a subject matter expert. And for the most part in NLP Logix, we like to work hand in hand with our customer because they know their subject matter far better than we do. So given that artificial intelligence is such a wide-ranging topic, why do we focus on debt collection? What makes debt collection interesting? And I think a big part of it is just sort of how prevalent the problem is. We know that 1 in 10 households has at least one debt in collection. There's $150 billion getting placed per year, and 27% of that delinquent debt ends up being collected. So there's a lot of money being left on the table, and the household debt is increasing year over year. But despite that, the Bureau of Labor Statistics is actually anticipating a significant drop in the number of jobs that are available in the ARM space, and that's due to the processes of automation and artificial intelligence.
So I'm going to put up a poll right now, and just to gauge how everyone is currently handling your scoring. Currently employing either a credit score approach, internal model, external model, no scoring strategy, or you're not sure. And it looks like most of you are actually using the credit score approach. So here's a little bit about kind of the issues with that approach.
So what we've found in using credit scores for debt collection, there's a couple big mistakes that we fall into. And the first is, mistakes on the credit report. The most recent survey had 26% of consumers had at least one mistake on their credit report, with 1 in 10 having a mistake that's large enough to cause a significant change in score. And that could be anything from a wrong name or a merged file to a mislabeled debt. We also run into the issue where matches can't be created, especially when you're only using a name and an address. It can be really difficult to make sure you're getting the right match. So, if you don't have any score being returned, then you have no strategy around that consumer at all. They're also slow to update, and they can be really troublesome when we're talking about non-debt transactions. So if you're talking about any first-party transaction or things like municipal debt, oftentimes a credit score can't be used for legal reasons. So when we look at the traditional approach to debt collection, I put up on the screen a really simplified version of, sort of a collection strategy based on a credit score. So I get a debt placed, and, they had a 520 starting score. So when they came in, we saw their credit score was 520. So we assigned them to our fair credit score group, and we put in a low level of effort there where we're calling them about twice a week, and we're going to send them one letter over the course of the time that we have the debt. So I go through the skip tracing process. I've got a new number for this consumer, but I'm still labeling them as a 520. And unless you pay for another credit score, you're going to go and you're going to continue to label this person as a 520 the entire time you have them until the debt's either paid or it gets returned to the creditor. So we like to approach the problem a little bit differently for NLP Logix, where we look at creating the Paypensity model. So it's the propensity to pay and the expected value generated from machine learning models. So instead of measuring whether somebody's able to pay, we're looking at the likelihood that they will pay. And we build these models using a de-identified set of data that includes information about the consumer. So that could be things like location through a zip code or a zip +4, some information about how you're able to contact that consumer, and the number of contacts that are available, the number of contacts that have happened with that consumer. And then we also get information about the debt. So when we look at information about the debt, we talk about how old the debt is, what type of debt are we looking at, what's the balance, and what's the balance in proportion to similar debt. And then we also get some information from external sources. So that might be something like the Census Bureau. So we'll get the Census Bureau data or information, if we're talking about healthcare, some stuff about the physicians, specific to the industry that we're looking at. So the model that we're actually talking about here, the underlying model, is a response model. So a response model takes a population of data, and as you run it through the model, what you get returned is a sorted population, where we're taking those people who are most likely to positive respond and boosting them up to the top of the list, and those who are least likely to respond and moving them to the bottom. So by sorting them from highest to lowest, we're able to best develop a strategy. So we're going to walk through our process to build a model, and we do this for every model that we build, whether it's something like debt collection or something that's as complicated as computer vision. We go through the process exactly the same way. We start with data gathering, we go to feature engineering, we do model building, optimization, and then we implement the model. So we're going to start with talking real quick about data gathering. That just means receiving the data from the client that we're working with. We do that through FTP, we do it through a remote desktop connection, or ODBC, whatever is the most convenient for our clients. And then we go through a process where we're understanding the data. So part of understanding the data might be doing some statistical analysis or building a dashboard like you see on the right hand of the screen. We also go through a process of cleaning and standardizing. We want to make sure if there's any outliers that we're treating them properly when we get into the process. And once we've gathered the data, we go through a process called feature engineering. So I know, everybody who's on the webinar probably saw our features bracket where we're looking at which of the features that are most influential in determining the score. And we've sort of categorized them into 4 areas. So we have information about the debt itself, information about the consumer, the external features, and then interaction. So how is the consumer behaving in their interactions with the agency? And, each of these is important. There's definitely some that carry a little bit more weight than others, but it's the combination of all of these plus feature engineering that gives us the best results. So feature engineering allows us to take some of those features that we've started with, like the median income and the rent burden percentage, and estimate the likely ratio between the debt balance and the disposable income. If you're asking somebody for a tenth of their disposable income, it's a lot different than if you're trying to take over, 3 months worth of disposable income. So once we've engineered our features, we actually get into the process of building the model. We have a generic template that we use for our debt collection-based models, but we customize the parameters to each customer, so we're optimizing best to your data. We go through a process where we make a training set of data, and then we build the model. And then we go through, once we've built the model on that training set, and test how well does the model perform on a test set that's held out, so we know that our model is going to work as well for you in production as it did in the lab. And then once the model has been built, we go into a process of optimization. So optimization can mean a couple different things. It could mean calibration, so making sure that 50% really means 50%. And then we also take a look at what we call hot pockets. So hot pockets is taking the predicted probability and the predicted expected value and balancing those together. We all know that the lowest balances are going to be the easiest to collect, and the high balances have the most sort of return. So we want to make sure that we're collecting on both sides. We're collecting from the people who are most likely to give you a high dollar return while not ignoring those low-hanging fruits. And then once the model's been through its process and we have our optimized results, the last piece, and I think where we really stand out, is implementation. So taking the model and actually getting wrapped up into your system. So it could be anything from an SDK deployment where we have an API that you call in order to get your model results, or an FTP exchange where you send us a file hourly or nightly or weekly, and then we return that file back in less than 30 minutes. We also, once we have the model in production, like to stay in contact and do analysis of how the model is performing. We want to identify when the model is going to need to be retrained and ensure that you're not seeing any change in performance over time.
So we're going to take a quick detour to kind of explain a little more about why dynamic scoring is super valuable. So as you can see, this stock information, this candlestick chart, you can see that over time, the information changes. The value of the stock changes. So imagine if you bought a stock and you were going to sell it a year later, but you had no access to any of the information as it developed. You would be stuck in a vacuum, not knowing about your stock. And as you can see here, there was an opportunity to sell high. Instead, a year later, with no insight, you're selling low.
So we like to think of the credit score approach sort of like that static approach, whereas what we encourage is a dynamic approach to scoring, where instead of creating one score per consumer and having that score live with them for the entirety of the effort that you're putting into the consumer, we're using a dynamic approach where we like to rescore the customer. For some people, it might be as frequently as once a day, it might be as frequently as once a week, but we always encourage that you rescore your account. So with the guy that we had earlier, started with a 520, he might go through our model process and start with a B-. So I'm going to give him a medium effort. And then once we completed skip tracing and I have new phone numbers available that were, recently imported, I'm going to maybe increase that effort a little bit, move him up to a B+. Whereas the credit score, we've still got that same 520 and we're not changing our approach here. Because I increased that effort to a B+ and have that mid-range effort, I actually sent an additional email to this consumer. And because he opened that email, I've moved him from a B+ to an A-. And I'm going to put in a high level of effort for this consumer, where with the credit score approach, we're still dialing him twice a week and nothing has changed. So once we put that high level of effort in, we actually see, a higher rate of conversion because we're putting the focus on consumers where the behavior and the model is sort of identifying people most likely to pay at that time. So another thing that we like to encourage is a decile-based approach. So here we have the bars, which are looking at the percent of people who pay, and the dollar signs is the total collections. And we're able to identify that in the top decile, which is just my top 10% of consumers, we're seeing a much higher rate of return versus when we get down to those bottom 10% where we're not really seeing much return at all. So oftentimes we'll see something like within 30% of the accounts that we're looking at, 73% of the dollars are coming in.
So here we're going to do another poll, and just when you're considering a scoring strategy, what are the most important things for your organization? Are you looking to increase collections, decrease efforts to collect, or minimize risk? Not surprising, it looks like most people are interested in increasing their collections. However, luckily with the Paypensity approach, you don't have to choose one. We cover all three to improve your business operations.
So as Sam said, we're consistently looking at all three of those goals. And we want to take a look, instead of just telling you that, we believe that this is what happens, we're taking a look at some real world examples of how Paypensity helped improve total collection. So we're looking at a large client that we work with that's focused in healthcare and telecom, but they do a little work outside of those spaces as well. And they've gone through 3 stages of debt collection. The first, they used a traditional credit score approach, and then they had an analyst that determined that there was some location-based statistics that he could incorporate that gave them a little boost on return. And since they were seeing such a boost from using their own internal data, they ended up partnering with Logix for the Paypensity model. So what we're looking at in the bar chart to the right is, in the gray, what was happening with that credit score plus an internal analytics piece. And then in the green, we're taking a look at the results for total collections with the Logix Paypensity model. And as you can see, we had about a 5.7% increase overall, a little more in telecom, a little less in healthcare, but consistently above 5% increases to total collections. Over the same time period, we were able to see a 13% increase in liquidity, an 8.8% increase in unit yield, and a 24% decrease in the time to contact. So what that means for that client is we're seeing a huge increase in the total collections with a lower effort going out in order to make that collections happen. We also have a couple other models in the debt collection space. One of them is Uplift. So Uplift modeling is allowing us to identify those people who are likely to be persuaded to pay via a letter who might not have otherwise paid. And that can really help in reducing letter spend by identifying the perfect group to send your letters to. We've also looked at call time optimization, which looks at the census features in order to identify where is the best time, or when is the best time to call somebody based on the environment they live in. We've also looked at risk mitigation through identifying when's the best time to credit report, and also clustering debtors, so identifying what groups of debtors pay well together. And just a couple final thoughts. We wanted to walk through, there's 4 really main areas that the Paypensity model can help you in your collections business. The first is the goal everyone seems to have. We want to increase collections, but we want to increase collections while decreasing the amount of labor and decreasing your contact costs. And then because you're targeting the people who are most likely to have a positive response, we also expect to see improved compliance during the time that you're implementing the Paypensity model.
And that is all for now as far as our presentation goes. We have left a little extra time for questions, and it looks like we have quite a few. The first question, how long does it take to implement the Paypensity model? Katie?
So the Paypensity model can be implemented between 2 or 3 months in order to get from receiving the data through building the model and having it back implemented with your organization.
And another question, how do you work in the healthcare space? Do you handle it differently than with other third-party collections?
So we definitely treat each industry differently. If we work with a client who works in multiple industries, we may build separate models that are specific to each of those. But then when we're within the healthcare space specifically, we're able to incorporate a little bit more data. So we know that OBGYN debt is the easiest to collect out of all the delinquent debts, and then emergency services are really difficult. So, I don't want to treat DME like it's emergency services. We want to make sure that we're optimizing at all points.
We have time for about 2 more. Do you work with debt buyers?
So yeah, we work with anybody in the accounts receivable space. So that could be the original creditor, a third-party agency, or a debt buyer.
And of course, the question of all questions, what does it cost? And of course, because we're building a model and we have a lot of work to do on the front end, there is an initial implementation fee and then a monthly charge based on the accounts that we are scoring for you and the use of the machine learning algorithm. If you have any other questions, please feel free to contact us at the phone number provided or at contact@nlplogix.com. We look forward to hearing from you.